We're given a rational function and asked to determine the y-intercept, x-intercepts, vertical asymptotes, horizontal asymptotes, and any possible holes in the function. When working with rational functions, it's often best to have it in factored form. Let's go ahead and start by factoring the numerator and denominator. Looking at the numerator, we would have a factor of x and a factor of x here. And the factors of negative 12 that add to negative 1 are negative 4 and positive 3. Looking at the denominator, notice how we first have a common factor of 2. Let's factor 2 out. That would give us x squared minus 2x minus 8. But this does factor again. We still have our factor of 2, and then we'll have two binomial factors. The factors of x squared are x and x. The factors of negative 8 that add to negative 2 are negative 4 and positive 2. One of the reasons it's important to factor our rational functions is, notice in this case we have a common factor of x minus 4 between the numerator and denominator. The reason this is important is that the values of x that make this common factor equal to 0 will not give us an x-intercept or a vertical asymptote. It's actually going to give us a hole. Again, since 4 makes this factor equal to 0, that means we're going to have a hole at the point where the x-coordinate is equal to 4. Once we know this, we can go ahead and simplify the function, meaning simplify out this common factor, leaving us with the function, the quantity x plus 3, divided by 2 times the quantity x plus 2. The graph of this simplified function will be exactly the same as the graph of the original function, except there will be a hole at x equals 4. Now to determine the y-coordinate of where this hole will be, we can now evaluate the simplified function at x equals 4. So f of 4 of the simplified function would be 4 plus 3 divided by, we'd have 2 times 4 plus 2. This is going to be 7. This will be 6 times 2 or 12. So there'll be a hole in the graph at the point 4, 7/12. Now that we have a hole here, we can use the simplified function here to determine the rest of the information. So to find the y-intercept of our function, we'll set x equal to 0, which means we need to evaluate f of 0. And we can go ahead and use the simplified function. So if x is 0, we would have 3 all over 2 times 2, which is 4. So f of 0 equals 3/4, which means the y-intercept is the point 0 3/4. Now to determine the x-intercepts, we set y, or f of x, equal to 0. And again, we're going to use the simplified function. And because we have a rational function, this function is only going to equal 0 when the numerator is equal to 0. Notice the numerator will equal 0 when x equals negative 3. Which means our x-intercept is the point negative 3, 0. Notice if we did not use the simplified function, we would make the mistake and assume there would be an x-intercept when x equals 4, but there's not going to be because the function is undefined at 4 and there's actually a hole in the function. That's why we have to use the simplified function. And then to determine the vertical asymptotes, these occur when the denominator is equal to 0. So x plus 2 is equal to 0 when x equals negative 2. Therefore, the equation of the vertical asymptote is x equals negative 2. And now for the last question, we want to determine the horizontal asymptotes, which can be found by analyzing the degree of the numerator and denominator. And we can use the simplified function or the original function. Notice in this form here, the numerator and denominator have degree 1, and since they have the same degree, the equation of the horizontal asymptote will be y equals the ratio of the leading coefficients. Notice the leading coefficient of the numerator would be 1, leading coefficient of the denominator would be 2. So y equals 1 over 2, or y equals 1/2, is the equation of the horizontal asymptote. Using this shortcut, remember, if the degree of the numerator was less than the degree of the denominator, then the horizontal asymptote would be y equals 0. And if the degree of the numerator was greater than the degree of the denominator, there would be no horizontal asymptote. Let's go ahead and verify our work by graphing the function. Here's the hole in the function at x equals 4. Here's our x-intercept of negative 3, our y-intercept of 3/4, our vertical asymptote of x equals negative 3. and our horizontal asymptote of y equals 1/2. So this graph does verify that our work is correct. I hope you found this helpful.